Hi guys, and thank you for joining me once again. Today we are going to be looking at looking at some of the exam questions, exam type questions that you come across in paper 1. So the main sections that you do cover in any type of revision session when you are practicing, even at home I'm sure, is functions and calculus. Those are the two big areas in any exam revision because obviously they account for a lot of marks. But please remember, when you are revising, do not ignore those smaller sections for 10% and 15% because everything adds up. And the most important thing you should do in exam revision is make sure you revise the areas that you are weakest on the most. Okay, so spend a lot more time on the sections you are weaker on to make sure that you ace those as well. Okay, so the first question we're going to look at is on functions and inverses. So this is question 1. So we have the function f of x is equal to a third to the power of x. We see this and we recognize hopefully that this is, hopefully you recognize that this is an exponential function. So f of x is equal to a to the power of x, where my base a is a third and x is obviously your exponent. So the first question says, is f an increasing or a decreasing function? Give a reason for your answer. So remember, when you have a look at your exponential graphs, there's two things that can happen. There are two shapes that you're familiar with. Either one that looks like that, or we have a graph that looks like this. So which one is increasing and which one is decreasing? So remember, if your x values are increasing as the y values are increasing, then you are dealing with an increasing function. So both of these obviously should cut on the y-axis there at 1. So if my x values are getting bigger and the y values are getting bigger at the same time, then I'm looking at an increasing function. So the graph in red will be an increasing function. If, however, your x values are increasing and the y values are going down, decreasing, then you are looking at a decreasing function, which is the graph in blue. So the graph in blue would be a decreasing function, the graph in red would be an increasing function. How you can very easily identify whether your exponential function is going to be increasing or decreasing, just by simply looking at the question, is by looking at the base. If a is a value between 1 and 0, so it's a common fraction, all your common fractions lie between 0 and 1. So if a is less than 1, bigger than 0, then indeed you will get a graph that looks like the shape drawn in blue. You get what we call a decreasing function. If a is greater than 1, you have an increasing function, which would be your graph in red. So for example, f of x is equal to 3 to the power of x. So the one that they've given us, we look at the value of a, we see that the base is a third, so therefore it's a number between 0 and 1. So therefore f is a decreasing function, and it's because our base is a number between 0 and 1. It's a fraction. Okay. So the next question, they say determine the inverse of f in the form y equals. All right, so let's just recap. What are the steps to find the inverse of a function? All we do is we swap the x and the y values, and then we solve for y again. So we go to the original equation, f of x is equal to a third to the power of x, and we're going to swap the x and the y values. I just want to get rid of everything else on the screen. So we've got y is equal to a third to the power of x. We can rewrite f of x as y. We then swap the x with the y. So then you get x is equal to a third to the power of y. And then the next step, once you've done that, to find the inverse, you then solve for y. So in other words, you make y the subject of the formula. Now in this case, because y is an exponent, the only way we are going to make this the subject of the formula is if we change from exponential to log form. And this is where you should, guys, realize that, of course, the inverse of an exponential graph is a log graph. All right, so you should already start thinking that, okay, I should be getting the equation that looks in the form of a log function. So therefore, how do I get to the value of y, which is my exponent? So my exponent y is equal to log of the number x base a third. So the base of the exponent becomes the base of the logs. Okay, so that would be your function f inverse of x. Now, even though the question doesn't ask for it, we could draw this, just a rough sketch, based on, so we know that a third to the x, if we said it's going to be a decreasing function, it's going to look something like that. So if your function, your f of x, is decreasing, then certainly your inverse will also be a decreasing function. It's not going to be an increasing function, it has to also decrease. We know that with log graphs, it does not have an x-intercept. Remember, with inverses, they swap around. So because the exponential graph has an x-intercept of 1, that means the inverse graph, which is the log function, will have an inverse of 1. Now we're looking at a log graph that's decreasing, so there are two choices here. So when you look at your log graphs, you either get one that does this, or you get a graph that does that. Again, it depends on what the base is, on which graph will be the decreasing and which would be the increasing. The graph in red is the increasing function, and that's where a, which is the base, is greater than 1. So that's where you're looking at bases of 3, 4, etc., etc. The graph in blue is your decreasing function. You can see that as your x values increase, the y values go down, they decrease. So therefore the graph in blue is the decreasing function. So the graph of y is log x base a third is going to look something like that. Okay, we see that with the exponential function, the x-axis is the asymptote. So with the log graph, it will be the y-axis that becomes an asymptote. So therefore the log graph will not touch the y-axis, it has no y-intercept, and the exponential graph has no x-intercept. So you know that because you're dealing with inverses, those two concepts will swap around. All right, let's have a look at the next question. So they say write down the equation of the asymptote of f of x minus 5. So remember, when we're looking at a graph of a third, an exponential graph where let's just say it's plus q here. Okay, so when we're looking at a graph that has a vertical movement where we've either added or subtracted a value of q, that's going to be a movement that shifts the graph up or down on the axis. So therefore, if we're looking at f of x, which was a third to the power of x, we are now subtracting 5 from that whole function. So therefore, your graph is moving 5 units down. So this graph in blue is going to move 5 units down the axis. So it's going to do that. All right? And remember, when you look at exponential functions in this form, y is equal to q becomes the asymptote. So therefore, y is equal to negative 5 will be the asymptote of a third to the power of x minus 5. All right, because we're simply moving this graph 5 units down. So you can almost think of it as your asymptote also moving 5 units down from 0, 0, 5 units down. All right. Okay, guys, so that's just a recap, really, a very quick recap of the big concept that you learn in grade 12, which is functions and inverses. And of course, the big new graph that you learn about is the log graph, which is the inverse of the exponential graph. So you just need to remember things like if the exponential function, the original function, is decreasing, your log graph is also going to be decreasing. If the exponential function is increasing, then your log graph is also going to be an increasing function. And the other thing that you need to remember is how to rewrite from exponential to log form. So it's not a huge section in exams, but you have to know how to rewrite your exponents as a log in order to make sure that that conversion from exponential to log form is correct. We're going to take a quick break. When we come back, we're going to be looking at the next big section that you do in grade 12, which is calculus. We're back after this. Hi everyone, welcome back. We are looking at the two sections, the two biggest sections in exams being functions and inverses and then calculus. So what we did before this was we looked at a graph which was an exponential graph and we looked at inverses, and now we're going to look at calculus. So this type of question, we've been given unknown values and we have to find the equation of the graph. So obviously calculus graphs, although it is a function, it falls under the section calculus. All right, so question 2, they say the graph of f of x is equal to ax cubed plus bx squared plus 24x minus 20 is sketched, okay? And I'm going to show you that just now. And it's not drawn to scale, of course. So we can straight away see that value of a and b are unknown. And for us to do much work on this question, we are most likely going to be asked to find the values of a and b. So they need to give us information, which they do. They say that the point A, 2, 0, is a local maximum turning point. So let's have a look at the graph. So there we have what we see is an increasing function. So I know that the value of a is positive. All right, so therefore, so remember, how do I know that? Well, you've got two choices for your calculus functions. They can either look like that or they can look like that. So if a is greater than 0, you have a graph that first has a maximum turning point followed by a minimum turning point. If a is less than 0, you have a graph with a minimum turning point followed by a maximum turning point. So just looking at the shape that they've given me, I know that the value of a has to be positive, and that's something I bear in mind as I work out the values as we go through the question. So you can see that a, the point A, is 2, 0, and that's a turning point and an x-intercept. B is the y-intercept, and C is an x-intercept. So they're basically stating what's already on the graph. That's your x-intercept, that's your y-intercept, so therefore we know b must already be negative 20. If we let x equal 0, I can see my y-intercept will be negative 20. D is a local minimum turning point, again telling you things that you know there. E is the point of inflection on the graphs. There we go. So that's your point of inflection. That's where the second derivative is equal to 0 and your concavity changes. So if we have a look at the graph, if we look at what happens before E, the graph is concave down. The way I look at concavity, and in fact, let me make that a little bit neater. If I draw a tangent line and it lies above the graph, then that graph is concave down. If I draw a tangent line and it lies below the graph, then the graph is concave up. So at the point E, your concavity changes from concave down to concave up. So therefore, you can tell that E is, in fact, your point of inflection. And that's where your second derivative is equal to 0. All right. First question says find the values of a and b. So let's have a look at what they've given us. We've got an equation where the values of c and d are known, and all we've got is the point A, which is your local maximum turning point. So using that information, how am I going to find the values of a and b? Well, there are two things you're going to do, because remember, a, which is the point 2, 0, is a turning point. So that means that my derivative f prime x at the point 2 will be 0. Okay, you know that whenever you solve for your turning points, that's when you say let the derivative equal to 0. So now the fact that they've given you the turning point, it means that the derivative at that point must be 0. So therefore, we know that f prime 2 is equal to 0. But we also know that 2, 0 is a point on the graph. So therefore, when x is 2, y is equal to 0. Remember, guys, whenever they're asking you to find two unknown values, you have to use simultaneous equations. So they need to give you enough information to help you to work out two equations that you can solve simultaneously. And certainly with this they have. If I've got the derivative at 2 is 0, and I've got a point in the graph, I will get simultaneous equations which I can solve to find the values of a and b. So because this is quite a long one, I've already done the working out for you, all right? So the first function is given as f of x is a x to the power 3 plus b x squared plus 24x minus 20. To find the derivative, I multiply the 3 by the a, so I get 3a, and then subtract 1 from the power, so I get x squared. Again, same process, 2 times b gives me 2b, subtract 1, I just get x, plus 24, the derivative of 20 is 0. Okay, and then the next thing we're going to do is we substitute the 2 in, f prime 2. Why am I doing that? Because that's the information they gave me, as I showed you before. So I substitute the 2 in place of x, and I end up with 12a plus 4b plus 24. But remember, because it's a turning point, we can equate that to 0, because at the turning point, at your stationary point, we know that the derivative is 0. So at any turning point, your derivative, your gradient is 0. So that gives me one equation. I've divided through here by, what is it? We've divided through by 4. So we get 3a plus b plus 6 is equal to 0. So that is one equation that we already have. Okay, we need another equation that comes from the fact that we can substitute 2 and 0 as your x-intercept into. Now we are dealing with the original function. We are not taking the derivative because we are looking for a point that is on the graph. Okay, so I substitute x is 2 and I get y is equal to 0. So by substituting 2 in for x, I end up with 8a plus 4b plus 28 is equal to 0. And then we divide through by the common factor of 4 to get 2a plus b plus 7 is equal to 0. Okay, and that's our equation 2. Now what we're going to do is we're going to solve the simultaneous equations, but we're going to use the method of elimination. So all we've done is we've rearranged. So we've taken 3a plus b, take the 6 over to the other side, so we get minus 6, and then 2a plus b, and we take the 7 over, so we get minus 7. Now remember, in the method of elimination, that's where you subtract the one equation from the other. So from equation 1, I'm subtracting, which means I'm changing my signs. All right, 3a minus 2a will just give me a, b minus b, they cancel out, and then we get 6 minus 6 plus 7, which just gives me 1. So therefore the value of a is 1. And that is great, because remember right at the beginning I said to you, well, I looked at the shape of the graph, I know that a has to be a positive number, and 1, a is equal to 1, is certainly a positive value, so I know that I'm on the right track. Once I've got the value of a, I can either substitute into equation 1 or 2 and then solve for b, and we get that b is equal to negative 9. So now our equation looks like this. F of x is equal to x cubed, because a is 1, minus 9. In fact, I'm going to run out of space there, so let's just put this further into the slide. So we're going to end up with f of x is equal to x cubed minus 9x squared plus 24x minus 20. And now that we've got the values of a, b, c, and d, we can answer any question about this calculus graph. Okay, so the next question says determine the coordinates of b. In fact, we've already done that. That was the y-intercept. X was 0 and y was negative 20. Okay, so if we go back to the graph and I just show you, b was the y-intercept of the graph. We then have to find the coordinates of c. Now let's have a look at what c is. C is the x-intercept, the other x-intercept on the cubic graph. Now remember, when you're dealing with cubic functions, in order to find the x-intercepts, we have to use the remainder and factor theorem, or the factor theorem. So what we do is we find a value that's a factor of the given equation. So in this case, the one we've just worked out with the values of a and b in place. We find a number that's a factor of that, and then we do either long division or division by inspection or synthetic division to get out all the other factors. In this case, because we already have one of the x-intercepts, the work is like halfway done for us, because we already know that x minus 2 must be a factor of this equation, x cubed minus 9x squared plus 24x minus 20. So therefore, I know that x minus 2 must be my factor. So therefore, whatever other division you're going to use, you can easily get to that second factor, x squared minus 7x plus 10. Either you're going to use division by inspection or synthetic division or long division to give you that. I prefer to use division by inspection. So what I would do is I'd get my factor, and then for my second bracket, I'd say it's the first term divided by the first term, so I'll get x squared. And then it's the constant divided by the constant. So minus 20 divided by minus 2 gives me plus 10. And there's something here that goes in the middle. It's going to definitely be a term with some kx. Either k is going to be 0 or it's going to be some other value. So I put in a plus kx. I then multiply these two together, the two that are right next to each other, minus 2x squared, and I multiply the first term by the second term. So I know that if I get minus 2x squared plus kx squared, that should be the same value as the b term, which is minus 9. All right, so I do a little equation here, and I solve for the k. So I end up with kx squared is equal to minus 7x squared, and therefore k must be equal to negative 7. All right, so that's division by inspection, but whatever division you prefer, you can use. We then factorize, and we end up with obviously x minus 2 squared, because we saw that that point was a turning point and an x-intercept. It makes sense that x minus 2 is squared times x minus 5, so therefore x is equal to 5 is the other x-intercept, so the point C has coordinates 5 and 0. All right. Let's look at the coordinates of D. Now D is, if we have a look at the graph, it's the minimum turning point. So let's just recap, how do we find turning points? To find a turning point, you find the derivative of your function, you then let that derivative equal 0, and you solve for x. Once you have the value for x, you then take the x value and put it back into the original function and find y. So let's very quickly go through finding the value of D, the coordinates, sorry, of D. So we've got our function with a and b in place. So first step is we find the derivative. So we get 3x squared minus 18x plus 24. We then set that derivative equal to 0, and we solve for x. When we solve for x, we see that we get x is equal to 2, which makes sense because that was the coordinates of a. Remember, a was 2 and 0, and we are looking for the values at D. So x is equal to 4 is the one we are interested in. When we get x is equal to 4, we then substitute that value back into the original equation f of x, and we see what our value f of 4 is. If you do all of that, easiest way is to just put that into your calculator. You'll get the function value is negative 4. So therefore D has coordinates 4 and negative 4, and D is your minimum turning point. And if you look at the graph to see if that makes sense, let's have a look. So D is somewhere there, and D has coordinates 4 and negative 4. It's certainly in the right quadrant, and if we didn't make any mistakes, then we know that we are on the right track with this question. All right, guys, so there we're really looking at some of the typical type of questions you can get in exams. The very last question asks us to find the coordinates of E, and they just want us to find the x coordinate of E. So all we do in order to get that is we take the second derivative. So we've just worked out the first derivative when we were working out the turning point at D. So we then take the derivative of that, and we get 6x minus 18. And we equate that to 0 because in our cubic functions, the point of inflection is always going to be at the second derivative equal to 0. And we therefore solve for x, and x is equal to 3. All right, so therefore the point of inflection has x value, x is equal to 3. That is all time we have to do this question, and that's good news because we've managed to come to the end of that question. It's quite a long one. A question like this will be worth plenty of marks in an exam. So hopefully we've gone through the steps that you needed to really just make sure that you get good marks on this question in an exam. All right, guys, until next time, take care. Cheers.